Question 14 says, calculate the amount of heat in kilojoules required to raise the temperature of a 79-gram sample of ethanol from 298K to 385K. And then it gives us a specific heat capacity of ethanol. So in the previous question, we calculated W in order to find delta E. Now here, we're trying to find Q. So here, Q equals M, the mass, in grams, times C sub S, the specific heat capacity, times delta T, the change in temperature. So we have some of these variables, but some of these variables we need to find. So Q equals the mass in grams, which is 79.0 grams, times the specific heat capacity, which is 2.42 joules per gram degrees C, times the change in temperature. To find the change in temperature, we need to take the final temperature, 385, and subtract the initial temperature, 298, and what you find is that this change in temperature is 87 K, or 87 degrees C. Remember that this is a change in temperature. So if we did this, we would take 385 K minus 298 K, which equals 87 K. Now, let's say we wanted to do this in Celsius. You can't convert the change in temperature to Celsius. You have to convert the individual temperatures to Celsius. So if we do this, we need to subtract 273, which in this case would be 112 degrees C, minus this temperature in C, which is 298 minus 273, which is 25 degrees C. And we'll see that the change in temperature is still 87 degrees C. So because this is a change in temperature, you do not want to convert this later because this is in C. Okay? Said another way, if you just plug in 87K here and you don't pay attention to the units, it's not going to make any difference. When we do this times this times this, we find that Q is 16,600 joules. Unfortunately, all our answers are in kilojoules, so we need to divide that by 1,000, which is 16.6 kilojoules, which is choice letter D.